Good morning, guys. Welcome to Tuesday. I hope you had a nice Easter. Today's lesson, I just want to go over a couple of little things to end up this first unit on linear relations, domain and range, all that good stuff. There's a couple of you who have already handed in your modules. It's important that you make sure to hand in that assignment booklet. If you're not going to actually drop it off, you can hand it in either by scanning and emailing it. There have been one or two of you who have handed it in to Google Classroom. That's fine too, but I've just noticed that it's kind of hard to draw the graphs and things like that in Google Classroom, so make sure you are very, very careful drawing the graphs. They have to look good, okay? They have to be accurate. So if you can't do that by editing the document and submitting it in Google Classroom, then you may want to consider actually writing out your answers on a paper copy, etc. And remember, please show all your work, okay? I can't give you partial marks if you just put an answer in there. So anyways, we'll get started. We're going to take a look at slope. For those of you who have done the physics unit of Science 10, whether you're doing it right now or you did it in the first semester, you're already familiar with slope, but many of you are not. Okay, so we'll just very quickly go over it. Slope is simply a measurement of the steepness and direction of a line. So there's always those two things to take into consideration. How steep is the line, and does it go up to the right or rise, or does it go down to the right or fall? Okay. The number that we assign to the slope will be positive if you have a slope that looks like this, that goes up to the right. It will be negative if it's the opposite, if it goes down as you go from right to left. Okay? Now, there are two other possibilities, right? You can have a line that slopes up, a line that slopes down, but you can also have a line that's perfectly horizontal. Okay, that's not going up or down. Or you could have a line that's perfectly vertical. Okay, again, two different possibilities. Horizontal lines have a slope equal to 0. So if you have a totally flat line, you will always have a slope of 0. It has no steepness, right? It doesn't go up or down. If you have a line that's perfectly vertical, this is a little weirder. If it's perfectly vertical, its slope is actually almost infinite, but what we say is that the slope is undefined. Okay? So we just can't say, oh, that's not even on there. Just a second. See if we can. Oh, look, there it is. Slope undefined. Okay? The variable that we use for slope is m, and that gives us a formula for slope of rise over run. In other words, what's the difference? What's the vertical change? And what's the horizontal change? Okay, now, you know that the vertical axis is the y-axis, and the horizontal axis is the x-axis. So, for any point A and B on a line, to get from one point to the next, you're going to have to go a certain number of units up and a certain number of units across. In other words, you're going to have a change in the vertical distance as you go up, and you're going to have a change in the horizontal distance as you go across. Slope is just an indication of that change, okay? So, just let me, in order to calculate slope, all we need to have is 2 points on a line, okay? If we have 2 points on a line, we can calculate slope as rise over run. So, again, slope is the symbol m equals the change in y divided by the change in x. And just a point here, it's an incredibly common mistake that students make where they will put the change in x on top and the change in y on the bottom. And you'll get it wrong. Okay, so please remember, it's change in y on top, change in x on the bottom. You'll have this on a formula sheet anytime you write a test, so just check your formula sheet. So for A, the first thing we need to do is we need to figure out what's the distance that changes vertically if we're going from this point A to this point B. Well, to get from A to B, the directions would tell you to go vertically 1, 2, 3 up, or positive 3, and then your horizontal change from A to B would be to go 1, 2, 3, 4, 5, also positive because you're going to the right, which is a positive direction, right? To go to the right is positive, to go to the left is negative. See all these negatives? So, what's our slope? Well, what's our change in y? Our change in y is 3. What's our change in x? Our change in x is 5. So our slope is 3 over 5. Okay? Now, really, it's as easy as that if you have a graph to look at. Okay? What about if you don't have a graph to look at? Well, I'll tell you what, why don't we do one more example? We'll do an example like F, okay? So the example we did for A was an example where a line sloped up to the right, and as we can see, if a slope rises up to the right, your slope should be a positive number. And you can see the number we got here is a positive number, 3 over 5. By the way, leave your slopes as fractions, okay? That'll be very useful in the next chapter. Don't convert your slope to a decimal number, okay? Generally, it's never helpful, okay? So just leave it as a fraction. So let's do one more. We'll do D, okay? So for D, you notice that as opposed to A, our line in D is going down as you go from left to right. So let's figure out the slope. Slope equals the change in y over the change in x. Well, what is the change in y? Well, we have to go 1, 2, 3, and this time, since we're going down, that's a negative 3, right? Down is more negative, up is more positive. So, our change in y values is negative 3. Well, what about our change in x values? To get from this point to this point, we then have to go 1, 2, 3, 4, 5, 6, 7, 8. And since we're going to the right, it's a positive 8. So our change in y was negative 3 because we went down. Our change in x is positive 8 because we're going to the right. And we end up with a slope that's a negative number. Well, that should make sense because you can see your line is going down to the right. So this is a negative slope. This is another negative slope. This one will be positive, as well as this one. Okay? Let's move on. So you're not always going to have a graph to look at, okay? Sometimes you're just going to be given numbers. For instance, this one says, determine the slope just given this information. Well, it says x increases by 1, y increases by 5. So remember, our slope is simply the change in y divided by the change in x. Well, what is our change in y? It says it's increasing by 5. Remember, increasing means you're going up. So that means you have a positive 5. Your x change is also an increase. That means you're going to the right, which is positive, and it's a positive 1. Now, this fraction we can simplify. If it simplifies to a whole number, that's good, okay? So 5 over 1 gives us a slope of 5. That would be a line that would be very, very steep, and since it's a positive slope, it's going to go up as you go from left to right. Okay? I'm going to have a sip of my coffee. So good. Okay, let's take a look at C, okay, because with C, again, we have our slope equals the change in y, which for C tells you y decreases by 2. Well, decreases means you're going down, so that means your y is going to be a negative number, right? But look at the x. The x is also decreasing. That means you're going to the left on the x-axis, right? Towards the more negative numbers. Also a negative. Look. We have a double negative. Remember, when you take a negative and you divide by a negative, you're actually going to end up with a positive answer, which in simplest form would be 1 over 2. Okay? So, even though you've got decreasing happening here, you're still going to end up with a positive slope, and this would look something like this. Okay? It would be shallower than our last one. Our last one was 5, so it was very steep. This one is a smaller number. That indicates a smaller or shallower slope. Okay? So that's slope. Now, as we move on, these are just lots of examples. Eventually, you're going to end up with examples where you're not given a graph, where you're just given 2 points on the line, okay? Now, if you're given 2 points on the line, our slope formula, change in y over change in x, can be rewritten as y2 minus y1 over x2 minus x1. Okay? Now that looks a little bit weirder, but it's essentially the same thing. Because of course, to figure out the difference between this point and this point, that you would have to go horizontally, it is just the difference in your x values, okay? If we look at an example like this one, okay? So, the coordinate of this point on the line is -3 and -1, right? You have to go 3 to the left and 1 down. So negative 3, negative 1. Well, what about this point? What are the coordinates of this point? Well, from the origin, you have to go 5 across, so your x is positive 5, and then you have to go 3 up, so your y is positive 3. Okay? Now, the way we just did it, we said, how far up and how far over do you have to go? Well, you have to go 1, 2, 3, 4 up. Since you're going up, it's positive. And then 1, 2, 3, 4, 5, 6, 7, 8 across. Again, going to the right is positive. So, your change in x is 8. Your change in y is 4. Well, look at what happens if we subtract our y values. Okay, so there's our y1, there's our x1, there's our y2, there's our x2. It doesn't matter if you say this point has the 2's and this point has the 1's or vice versa. You'll get the right answer. Well, if we take y2, y2 is negative 1, so where you see y2, you plug negative 1, and y1 is positive 3. On the bottom, our x2 is negative 3, so we're going to plug in negative 3. Our x1 is 5, so we're going to plug in 5. Okay? Simplify. Negative 1 minus 3 is negative 4. Negative 3 minus 5 is negative 8. And as we discovered just a little bit earlier, if you have a negative divided by a negative, they will cancel, leaving you with a positive answer of 4 over 8. Now look at what we had over here. We said that our change in y was 4 and our change in x was 8. So, whether we use this formula or the slightly different one, change in y over change in x, we'll still end up with change in y is 4, change in x is 8. You see, we have the same answer regardless of the formula we use. Okay? So, when you actually have a graph you can look at, this is probably the easier one to use. If you're just given 2 points on a line, like with these ones, then you've got to use the kind of more drawn out one. So we'll do one of those, and then we're going to call it a day on this, because we're up at 18 minutes already, and I don't want to bore you too much. Okay? So, let's determine the slopes of a couple of these. We've got these 2 points, and we're just going to say this one will be our x1, y1, this one will be our x2, y2. It doesn't matter which goes where. Okay? So our slope formula is y2 minus y1 over x2 minus x1. Plug in the values that you've been given. y2 is 8, y1 is 5. x2 is 3, x1 is 1. Simplify. 8 minus 5 is 3, 3 minus 1 is 2. So your slope for this particular one is 3 over 2. And again, unless it reduces to a whole number, just leave it as a fraction, it's fine. Okay? We'll try, I don't know. Why don't we do D? So for D, Our y2 is 4. Our y1 is negative 5. So minus negative 5. Our x2 is negative 3. And our x1 is 2. Okay? Do your subtraction. 4 minus negative 5. Remember, that's like saying 4 plus 5 or 9. Negative 3 minus 2 is negative 5. Now, this is just me, but I get into the habit of, if I have a negative sign, I always just move it up to the top number. Okay? You don't have to. 9 over negative 5 and negative 9 over 5 will simplify to exactly the same thing. So it doesn't really matter. It's just a matter of getting into a habit that you use every time, so you don't really have to think too much about it. Okay? So, negative 9 over 5. And that is slope. I think probably that's enough for today. It's been fun, and see you again next time.